Now class, let's move to the next function, which is radical function in the form of f of x equal to square root of g of x, where g of x is a polynomial function. You must make sure the expression inside the root is not negative. For square root, the expression inside must be greater than or equal to 0. So to find the domain for this particular function, first we solve the g, we make sure that the g of x must be greater than or equal to 0. Then we write the domain as the set of all x values that makes g of x greater than or equal to 0 true. So it means that we write the domain in such a way that it will be in the form of range, but the range will be the side, will be favoring the side that will make g of x greater than or equal to 0 true for its nature. So let's look at an example here. We have f of x equal to square root of x minus 2. Now I have to write the domain in such a way that x minus 2 will be greater than or equal to 0. Saying this one is an inequality, I'll solve it. And the inequality x minus 2 greater than or equal to 0 will be solved as x greater than or equal to 2. So if I want to write the domain, it means that the function will be able to produce an output only if I produces an x value or I substitute x value that will make this whole expression be greater than or equal to 0. So the domain will be such that this x that you see, the input that you see, can be any real number. It is defined for any real number. It's a member of any real number. And that real number supposed to be a real number greater than or equal to 2. That means from 2 and above in that particular range, because any number that will be 2 and above will make the s minus 2 greater than or equal to 0 true. So let's repeat the same thing for the example 2. For the example 2, we have f of x equal to square root of g minus x squared. So here we set the 9 minus x squared to be greater than or equal to 0. And we solve this particular inequality. And when you solve the inequality, the range that will make this particular relation or inequality true will be a range from -3 less than or equal to s less than or equal to 3. So only that range will help us or will make us get an answer for this particular function without putting it into an error form. So you are going to end up getting x squared to be less than or equal to plus or minus 3. Then when you text the range, you are going to put numbers from the back of the 3 and from the back of the -3. So if you use 4, for example, 4 will be at the back of +3. So when you substitute 4 here, it will be 4 squared, which is 16, and 9 minus 16 will give you a negative number, which is not true for this particular relation. When you choose -4, that is from the back of -3, you will substitute it as x. It will give you 16 here, and 9 minus 16 will repeat the same process. It means that numbers at the back of 3 and numbers at the back of -3 will make the whole function goes to max error. So if I want to write a domain, then the domain will be numbers between -3 and 3. Let's text a number between -3 and 3. example 0. When you put 0 here, 0 square will be 0. 9 minus 0 will be 9, which is greater than or equal to 0. It means that numbers between this range will make the statement what? True. So which means the domain will be x being a member of R, and x supposed to be numbers between -3 and 3, because that is the only range that makes the statement true. Let's look at the graph view of radical function. So this is a square root function. Look at this, a square root of x minus 1. You can't take the square root of a negative number in real numbers. So we set the inside of the square root x minus 1 greater than or equal to 0, which means x must be greater than or equal to 1. So the graph confirms this. It only starts at x equal to 1 and goes to the right. So when you look at x equal to 1 is at this side, you'll be seeing the graph going to the right, moving to the right in a smooth form. It means that all those numbers at this side will mix, at this range will makes the function defined, will make us get an answer for the function. That's the reason why you see the graph moving at this side. You are not going to see the graph moving at this side because it has break from this side. It doesn't, you won't see or any x value that is less than 1. Any x value less than 1 will make the function undefined. So the graph will be moving towards the right direction as shown on the graph. Good. Let's move to the next one, which is logarithmic function, which is also log of x. So to write the domain, this means that the domain is all positive real numbers. So log the x that you see here, the input will be defined for all positive real numbers. So it means the negative real numbers are not part. So if I want to write the domain will be x is a member of R, and x supposed to be greater than 0. X supposed to be greater than 0. So look at example 2 here, x minus 4, log of x minus 4. So here the x minus 4 supposed to be greater than 0, which means that the range will be all x value greater than 4. So anytime I use x value greater than 4, I'll be able to get an answer for this particular log function. If I use numbers less than 4, less than or equal to 4, it means that I won't be able to get the answer, and that is the restriction on this particular graph function rather. So the domain is s is said that sm of r, and s supposed to be greater than 4, or it can also be put in this way: s is said that sm of r, x cannot be less than or equal to 4. That means except when x becomes less than or equal to 4. Okay, let's move to the next. That is the graph of logarithm function. Look at this one too. The graph of f of x go to log x minus 3. So logarithms are only defined when their input is greater than 0. That is what you have to put in mind. Anytime their input is greater than 0, the logarithm function is defined. So for log x minus 3, we must have x minus 3 greater than 0, which means x is greater than 3. So because of that, it will start from the 3 and move straight to the right side. The left side will not be acceptable because the restriction is saying that the value of the x supposed to be greater than 3. So all those at the left side will make the function undefined, goes to mass error. That's the reason why you can't see any curve at the left side. But there is a curve at the right side moving this direction. Exponential function is here, which is also of the form ab raised to the power s, where the x represent the input. The input is the index, the power, or the exponent. So for the exponential function, it behaves like the same as the polynomial function. The domain, there is no restriction on it. S can be any real number. For example, f of x equal to 2 raised to the power x. So the domain is such that s is such that s is defined for any kind of real number. All real numbers will produce an output. So that is the exponential function. Let's look at the graph of exponential function. So this is exponential function, f of x equal to 2 raised to the power x. So the graph can move in this direction here. It is smooth and continuous, and there is no break. So the domain is defined for all real numbers. So let's go to an advanced section here. So when you look at this advanced section, it contains both fraction and square root. Remember, here the correct number is supposed to be so let's look at this particular slide here. Is that it is an advanced example. It's a combination of both rational and radical function. So the radical function is serving as the denominator for this particular rational function. So we need to put in mind that rational function is undefined when the denominator goes to 0, and the radical function is also undefined when the whole expression under the root sign becomes less than 0. So this expression under the square root must be, so the expression under the square root must be greater than 0. That is what we need to put in mind, because the moment the expression here becomes 0 and below, the whole function becomes mass error, because when it becomes 0, it becomes, the whole thing here becomes mass error because of the rational function, because the denominator cannot be 0. And when it becomes less than 0 to, under the square root, you have negative of square root of negative numbers being rare, so both of them will be affected. Then in simple short, everything here is supposed to be greater than 0, like the way I have written it here. So it's supposed to be 13 minus x greater than 0, which means that what the inequality will be x less than 13. So the domain for this function will be in such a way that x is defined for all real numbers and s must be less than 13. The moment s becomes less than 13, then this one, or this particular function, will give us an output when we substitute the input. So the input is supposed to be a number less than 13. So for example, when you take 4 for example, 13 minus 4 will be less than will be greater than 0, which will make the function defined. Now let's go to real life examples. So for the real life examples, a phone call charge is given by this particular function, where s is a number is a number of minutes. So there is no restriction on this particular function, and s is greater than or equal to 0. So look at this particular examples here. Let's come to volume of a cylinder. The volume of a cylinder is in this form, as pi r square h, where h is height. So the domain for the height will be height supposed to be greater than 0 before we can be able to find the volume of a particular cylinder. Let's now let's move to the next slide, which is real life example of domain. So a phone call charge is given by c of x equal to 0.10 x plus 1, where x is the number of minutes. There is no restriction on minutes. X is greater than or equal to 0. So here, no restriction on the minutes, and the minutes will be x greater than or equal to 0. So you'll be able to get know your charge. So let's look at delivering fee. So the delivery fee here is d of x equal to 3.5x plus 10, where x equal to distance. So this times x supposed to be greater than or equal to 0. Then let's look at volume of a cylinder. So here this is pi r square h, and the domain h supposed to be greater than 0. Then we go to the investment growth, that is like compound interest, where t is a time in years, and here the domain is such that t is supposed to be greater than or equal to 0. So thank you. I'll be meeting you in the next class. Make sure you subscribe and wait for the next class. Thank you.